Hi, everyone. I'm super excited that you're going to be joining AP Physics 1, or if you're a parent of one of the students. My name's Joel Klammer, and I just wanted to give you a quick introduction to the course and tell you a little bit about the exam and a few other things. This is my 16th year at Concordia. It's been a long, long time. My wife, Jane, teaches high school art, so you might have her as well. She's currently in the U.S., but hopefully back soon. My daughter, Katie, graduated from Concordia quite a few years ago. Went to Concordia University, Chicago for undergrad, Michigan State University for med school, and is currently a resident in OB/GYN at Cleveland Clinic in Ohio. My son, Aaron, many of you know him. My apologies in advance for the old photo down below, is going to be a sophomore this year. I'm super excited when he gets back as well. Currently, I'm teaching AP Physics 1, AP Physics C, Engineering, Algebra 2 for a short time, and Applied Marine Research. Originally, I was in Michigan. Then I taught in Chicago for 7 years, then Hong Kong International School for 12 years, and for the last 16 years, I've been here happily at Concordia, Shanghai. I love physics. I've got to admit it. I know it seems a little strange. I used to work at Fermilab, which is the national accelerator lab in the U.S. outside of Chicago for many years, and at CERN, which is, I always get my French wrong, is a large European accelerator in Switzerland and France. Currently, I'm a Large Hadron Collider LHC fellow, so I get to go travel around the world and talk about particle physics. And I help write the Global Physics Bowl exam, where students worldwide take it to sort of see how they do, and it's sort of a global friendly competition. My hobbies include scuba diving. I'm an instructor. I love ice hockey. I haven't had a chance to play it lately. Muay Thai and boxing. So a little bit about myself. A little bit about the course, if I can get there. Sorry, before I even get there, a little bit of the screen's cut off. Here's my contact information, which is probably one of the more important things in this video. You can email me anytime. You can call me on my cell phone or send me an SMS. You can Skype, although I haven't used Skype in a long time. WeChat, of course, the ubiquitous form of communication. And my home phone. You can also scan this QR code to add me on WeChat. I'm available before school from 7:30 to 8:30 in the morning, every morning except when we have science department meetings. And after school every single day as well, although I do need to tell you that some days I'll be down in the engineering lab, but students can still sort of multitask down there with me as well. A little bit about the course. AP Physics 1 is one of 3 AP Physics courses available to students. AP Physics 1 and 2 are each year-long courses that cover the complete unit of a typical algebra-based university course. College Board years ago took the AP Physics B course, which was the algebra-based physics course, and split into 2 years because it was just too much material. I know, I used to teach that course, and we would cover a unit every single week, which was just too much material. I do like it now, but it does go a little bit deeper. AP Physics C is a calculus-based course that focuses on mechanics and electricity and magnetism, and typically it's a second-year course. So many of the students who take AP Physics 1 have the option, if they're not a senior already, to take AP Physics C next year. You can read the College Board description here in the next section. The topics we're going to be covering are kinematics, dynamics, circular motion, gravitation, energy, momentum, simple harmonic motion, torque, rotational motion, electric charge, electric force, DC circuits, mechanical waves, and sound. That's a lot of material, even though this is a cut-down course. The other thing the College Board requires is that 25% of the instructional time be spent in hands-on laboratory work, and with an emphasis on inquiry-based investigations. We'll talk more about this. This doesn't mean that they're going to spend 25% of the time doing formal labs. It means a lot of small, what I call mini labs, where you're investigating something and trying to come up with some ideas about what it means. Algebra 2 is the pre or co-requisite for the course, particularly we require most students to have finished it before they begin this. This course is ideal for students who are likely going to an engineering, medical, or any kind of science field. It's nice to get this one in high school where you can spend a little more time with it. Here's the textbook. It looks like this. This is the hardcover book. It says College Physics. Don't let that scare you. Nothing in there beyond algebra. And in addition to that, we'll be using an online edition. This is called College Physics for AP. It's an ebook. It's one of the OpenStax books, and this one's purely electronic, so you won't see a physical copy of this one. The physical textbook, the students can take home and keep there to work. They don't have to drag it back and forth, because it is pretty heavy, actually, I have to admit that. The assignment sheets are posted regularly. They look something like this. You'll see 2 different days listed here. Last year I had a class that met on a day 1 and a class that met on a day 2. You'll see the topics that we're going to be covering, the readings that we'll be doing, and the assignments. And you'll notice that a lot of these are hyperlinks, because they'll actually take you to the pages so you can see them, and you'll see solutions are also posted. Homework, most of you know this already. Labs are graded, tests are graded, quizzes are graded. Quizzes usually based on the homework. But actual homework book assignments are just graded for completion. So it's a very, very simple thing. They don't count towards the final grade. You can access their current assignments using this QR code at any given time. It'll take you to an HTML page that simply shows this page. In addition to that HTML page, you'll also find it posted on Canvas. So if you go to concordiashanghai.instructure.com, you'll find the AP Physics 1 homepage, and over here on the side here you'll see daily plans, and that'll take you as well to that assignment sheet, so it's very easy to find. In addition, on here you'll find the course welcome, which hopefully you're watching, or this is how you found it, the course syllabus, resources, graded assignments, the lab safety contract, and any online quizzes will be posted here as well. Oh, there, sorry, I've got it highlighted. I want to show you just a little bit about some of the homework they'll be doing. This is actually some parts on it. It's designed to develop conceptual understanding. The idea here is that all the formulas are provided, so this is not about memorization. It really is about trying to understand the concepts involved. So you'll see here a quick example. Given this position versus time graph over here, which would be the corresponding velocity versus time graph? You've got graph A, B, C, or D, and students very quickly realize, oh, wait a second, I'm moving away from the origin at a regular rate here, position's increasing, must mean I've got a constant positive velocity. Or mathematically, they soon realize that the slope of this curve tells you what the velocity is at each instant. In this case, it's a constant positive slope, which means a constant positive velocity. Here's another quick example. In this case, the position is increasing with respect to time. It's getting faster and faster and faster. The question is then, which one of these graphs would correspond? And most of you can sort of see it at this point. You're like, oh yeah, of course it'd be graph D. We also run into these kind of ones. These are called ranking activities, where you have to rank these. In this case, there's a picture taken of the object every single second as it moves along this number line. And you can sort of see here, this object is moving at a constant rate. This object here is object B is picking up speed. Notice it's covering a greater and greater distance each unit time. C is moving fast, but at a constant rate. And D is moving rapidly to begin with, but then slowing down. And the question is rank the magnitude of the average velocity over the first 3 seconds. So in this case, here's 0, 1, 2, 3. It moves 6 meters in 3 seconds. In this case, it moved here, 1, 2, 3, moved 2 meters. Here it moved, oh my goodness, 9 meters. And here it moved 1, 2, 3, 9 meters as well, from 10 to 1. And so the ranking on this one, the largest one are C and D both tie at 9 meters, followed by A, followed by B. And these kind of ranking activities are very common in AP Physics 1. I also am going to give them a conceptual pretest. Don't worry about this. This one always causes stress for the students. Just to see, there's a lot of preconceptions and misconceptions that people have about how the world works. And so in this case, I don't know if you can see this very well, but the person here is swinging a ball in a circular path, and at point P, the string suddenly breaks. And the question is, what's the ball going to do after the string break? Will it go through path A, this direction? Will it go B? Will it go straight out this way? C? Will it kind of curve out like this? Or will it go straight out like E? And this one really kind of checks things to sort of see what kind of misconceptions or preconceptions they might come in with. The correct answer on this one, if you're curious, is B. It always goes out as a tangent because that's the direction the ball is moving at the instant that the string breaks. Yes, it'll actually fall towards the ground, but from a bird's eye view from up above, this is the path it would take. Like I mentioned before, we have to do quite a bit of assessments. We'll do a lot of small mini labs. In this case, this little red car here travels at a constant velocity, and this card here has a fan on it, and the fan actually makes this car gain velocity at a regular rate. It accelerates at a constant rate. And they have to actually calculate a formula that describes the position of either one of these, and then, using those formulas, predict where they would meet if the red car has a head start when we begin. And I'm going to quick show you a video of this from last year just so you can sort of see what it looks like.
Well, I'm nervous. Go.
It's coming, approaching, approaching, approaching. Boom!
That was kind of...
And in this case, the group did actually very, very well. They actually did predict where it would actually meet. So you kind of get a feeling for what kind of mini labs I'm talking about. I did want to show you, though, also what kind of questions are typical on the AP exam. You'll notice immediately that the type of questions are not mathematical ones. They're almost all conceptual multiple choice questions. They're not plug and chug. All the formulas are given to them on the AP exam. They have them there for reference. They can use their calculator the entire time. But it really is meant to see, hey, do you really understand what's going on in this case? So a little bit about the exam. There's 45 single select multiple choice questions. That means where there's just one correct answer on these. There's 5 multiple select multiple choice questions where there's 2 answers that are correct. And that's 90 minutes of the exam, and we're 50% of the final score. And then there's 5 longer free response questions, also 90 minutes, and that's worth the other 50% of their score. Here again are the units on the side. Sorry, it's a little bit cut off. The last one's mechanical waves and sound. But here's kind of the example one. Block Y falls on block X. It compresses the spring for a brief moment before bouncing back off again. And the question is, what's true about the forces that block Y exerts on X, the force that block X exerts on Y, and the force of gravity on Y? And in this case, if you haven't quite figured out yet, the correct answer here is A. The force of Y on X is always equal to the force of X on Y. It's a contact force, Newton's third law. But the force here has to be larger than the force of gravity, so that block Y is going to accelerate upward right after this. And then here's a free response question. My apology again is slightly cut off, but you can sort of see what's happening. Whoops, I'm sorry, I'm missing a picture on this one. There's a sphere suspended by a string. I guess I can kind of quick draw it on here. And the question is what's happening to the sphere? So you have a sphere, and it's going in a circular path like this. And the question is all right, the students are talking about it, derive an expression for the magnitude of the force. But before that, in part A even, you're having students talking about it, and they have to say, you know, what's one aspect of the reasoning that's incorrect or correct? What's one aspect of this student's reasoning that's correct or incorrect? And so it is a bit of narrative, a little bit of essay. And then down here, you have to actually figure out the forces involved, given that this thing is swinging at some rate, at some angle theta, and you're trying to figure out, all right, what's the force exerted along this string of some radius? And when you know that there's a force of gravity on this equal to the mass of the object times the acceleration of gravity. And so you've got some mathematics as well, but these are what a free response question looks like. In the next slide, I want to give you a quick view of what the room looks like. If you're a student, you're going to be in this room. But for parents, because I'm not sure if we're going to have back to school night this year, I actually want to sort of quick give you a view of the room and what it's going to look like. So here it is looking out the window. You can see downtown. And then this is a view. My apologies, the room's not completely set up yet, but I sort of want to see it. We've got cabinets and cabinets full of physics equipment and monitoring equipment. Just around the room. Here's the fume hood. We don't use that too often in physics. Here's the front of the classroom. You can see my desk and the front whiteboards and the monitors. You can see the student desk where they'll be sitting, 4 students to a table. There's the entrance door. Here's the other side of the room. Lots of equipment. Physics requires lots of toys, lots of things to work with. And then back around to the back of the room. Yes, the entire back wall of the room is solid windows from top to bottom with a great view of Shanghai and downtown. And we're back again to the beginning. So yeah, it's a really nice room to teach in, except it gets a little warm in the afternoon when the sun is shining in. Finally, just to wrap things up, if I can get to it. The most important thing again is please contact me as a student or as a parent. There will be a class WeChat group, so if students have questions, they can ask in the group and they can reply to each other, or if I don't reply immediately. Again, if you would like, you can add me as a parent as a WeChat contact and ask me questions anywhere along the way. Again, I'm super happy that you're going to be here to join us, and I'm super excited about the course. This will be fun. Thanks again for listening. Bye.